Okay, hello everybody. So my name's Nicola and I am going to be giving this talk about biomimicry and nature as teacher. So I'm going to give you a massive download and fly through some of the well-known things about biomimicry, but also some things which are kind of coming through new, and some of the companies that are already working with it. And then at the end, if you can kind of open it up and have any comments or questions. So somebody's saying that I have frozen. Have I frozen for everybody? No, sorry, Carol, then I think it's your computer there. So anybody that has arrived late, if you can also just put where you've come from. So that would be great. So I am going to share my screen with you and get this show on the road. So here we go. Nature as teacher and inventor. So first of all, we always start with, well, what is nature? And for so many people, they kind of see this separation between, humans living in these cities and then nature as the national parks. Nature is the other place. It's where we go on holiday. So, just to kind of clarify and remember that we are nature, we are not separate from it. And for us to kind of, as humans, come back into a place of remembering that we are just like any other species on this planet. And we're all doing the same. We are feeding our young, we are finding a house and a shelter for ourselves. And, it's like we're all doing the same thing in surviving. But the way that, when we talk about nature as in the natural world, that has existed forever and how it has adapted and evolved, and way that the humans have come in and thinking that, it's okay, Carrie, I'm going to have to hand this over to you. I hope you haven't just gone out.
No, I'm here.
Oh, okay, I've lost you. I just saw 3 people have just
entered.
It's
Stephen McDonald, who's trying 3 times on 3 different devices to get in. So, and he's been trying for a while. So sorry.
Okay, no worries. So yes, but when we look at this coral polyps and we see, what the coral's doing with exactly the same building blocks as we have, calcium carbonate, that's what it is surrounding itself with and making its home, making its protection. So, we have exactly the same here in the South Downs National Park, the White Cliffs of Dover, where we are in the south of England. And this is, millions, billions of years of exoskeletons that, they're dropped to the bottom of the seabed. And this material, this calcium carbonate, is what limestone is made out of, which is what those houses are made out of, cement. So, it's the same thing that we are building with. But the way that humans work, in that we mine everything, and and by heating it and beating it and treating it, we use huge amounts of energy. Having to create cement, it needs vast temperatures. It's a toxic chemical process. And then once we've blasted it and dynamited out of the ground, we then have to pack the cement and ship it. So, nature's design is not quite as elegant, human design, as nature's design. So here, with the same building blocks of calcium carbonate, this coral reef has built itself to the size and the shape it wants. There's no waste left over. It hasn't been packed and shipped. It's on site, been built. And it's a process that's been going on for millions of years, and it works. And so it is replicated. Now, Janine Benyus, hats off to her. She's the person that really got biomimicry on the map. And I think this is a very good quote from her when she's asked, what is biomimicry? The conscious emulation of life's genius is a survival strategy for the human race, a path to a sustainable future. The more our world functions like the natural world, the more likely we are to endure on this home that is ours, but not ours alone. So I think that that's kind of like well wraps up, actually, what is biomimicry? It is us learning from nature, mimicking it, and seeing how we can solve some of the critical problems that we have in the world today. So there's three kinds of biomimicry. We've got looking at form, the shape, the surface, the texture. There's the process, looking at the kind of the operations behind how it does what it does. And then there's the whole ecosystem, when you're really putting and seeing how everything works together. So breaking that down into form, looking really closely, and I mean, sharks are one of the greatest examples, because they say they can't evolve anymore because they have reached this point of like perfect evolution. And when you look in really close at not the scales of the shark's skin, then you see this form. And this company, Sharklet Technologies, have created a new surface, a new fabric. And I mean, it was known in the Olympics that it was actually banned for use in the Olympics because the swimmers that were wearing it were obviously able to move faster through the water. But also, if we look at today, where we are just having to constantly spray surfaces to keep bacteria and virus, we're using all these toxic chemicals. But if we look at a shark and we see that nothing adheres to its skin, if we were to cover restaurant surfaces and doorknobs and, change the way we actually look at things, rather than having to keep cleaning it, create a different kind of surface that nothing can actually stick to. Process, like I spoke about before with the coral. And there are companies which are doing carbon capture. They are taking CO2 out of the atmosphere, they're converting it back into calcium carbonate and creating building materials, which is obviously kind of a no-brainer, and we need a lot more of that. And then we've got systems. And I remember years ago, I went to visit a place up in Scotland, Findhorn, that had one of these living machines, and all the waste from the toilets came through a series of different kinds of plants which filtered it. Each part of the system did something different, and in the end, the water was totally clear that came out the other side. There's a company called Zeri Systems, and they're also looking at how can we really close the loop, just like nature does, no waste. How do we create more from, instead of, this is an example of coffee plants, instead of just having coffee and then throwing the waste away, actually, if we look at all of the waste links, what else could be produced? This is a clearer example here, a beer company. And instead of just selling beer and then having a whole load of waste, they're like, well, actually, from the waste grains, you can grow mushrooms or bread. And then when the mushrooms are spent, they can be fed to the pigs. The pigs then produce manure, which can be turned into compost, also putting it through an anaerobic digester. You can create gas. The water waste, it goes into an algal pond and there's fish. So it's like, well, instead of just selling beer, they're selling beer and bread and mushrooms and bacon and compost and gas and fish, and it goes on. So, it's looking at these systems and really closing the loop on them and seeing differently. For so long, we've just learned about nature. We need to learn from it. So that's the shift. So instead we would, kind of look at this tree and say, well, what's its scientific name? How long can it live for? How tall does it grow? What are the uses for it? Where does it live? And instead, if we shift the questioning to learning from that tree, and so, how do you, without using any toxins, how do you grow? How do you transport water, up? ridiculously high. And I remember once being in a Eucalyptus regnans tree, and the tree itself was 82 meters high. And so to think that water is getting pumped up to all these extremities, how is it doing it? Sometimes you see trees bending over on such a gradient that we would think that it's against gravity. How are they actually holding themselves up? How do we purify water? Because right now, all the kind of water companies around use huge amounts of energy and chemicals in the purification of water. So one of the new findings was this Aquamidate, who have been looking at these amazing diatoms, which are found in all waters around the world, in any kind of moist soil. And, they're thinking there could be up to a couple of million different species that still have not been studied. But what they do is a really efficient way of filtering water. And they are surrounded by silica. And so this company is looking at how to produce a really, water purification technique, which doesn't need to use a lot of energy, doesn't need to use chemicals, and it can actually filter out all sorts of contaminants and plastics and pharmaceuticals. So, seeing what is actually coming from these people that are learning about biomimicry and today's problems that we're facing, and actually moving forward in some really exciting ways. So architecture, Michael Polwin wrote a great book years ago on biomimicry and architecture. And if we look at, the classic pine cone and how adaptive it is, when it is wet, it closes. When it is dry, it opens. And so it's like they're saying, well, hang on, what about if buildings did the same? Buildings, and they have already created this, buildings which with this wood are able to, on hot days, it can open. When it's rainy and cold, it closes. Fabrics can do the same. Imagine the future of fabrics, which, when you're hot and sweaty, the fabric opens, and when it gets cold again, the fabric closes. And this is learning from these pine cones. But over the years, there's been many buildings that have been inspired by nature, going back to in London, Crystal Palace. And the architect was actually working with one of the people from Kew Gardens, and they were looking at this giant Amazonian water lily and looking at the structure of it, because they wanted to create a building that didn't have lots of internal pillars, which is more recently what they've also done in Stuttgart University. They wanted to build some big temporary exhibition spaces. So they looked at sea urchins and the structure of them so that they could actually mimic and create spaces without needing to have lots of internal structures. These termites in Africa, and this brilliant, in Zimbabwe, the Eastgate Center, which was mimicked, learning from the termites. And they explain it like the termite mound is like a lung which breathes. And it's like, it's this incredible system, which they filled with cement and then, it excavated it to see how the structure worked. In the desert, in Africa, it's very hot during the day and very cold at night. But if you take the temperature in the very middle of the termite mound, it stays the same temperature all the time. So this building, it's a huge shopping center underneath, all these apartments, and there's no air conditioning or heating. And the building stays at a constant temperature. Now, as refrigeration is what the absolutely worst thing for climate change. And if you look at drawdown, which explains the biggest solutions, actually refrigeration is the #1 biggest solution to deal with climate change. And that is because hydrofluorocarbons are thousands of times worse than CO2. And we can focus a lot on carbon dioxide and without realizing that there are other gases which are much more harmful. So, you know, we really need to kind of like move the future of architecture. So we're not needing to keep heating and cooling our spaces. And they've been looking at other ways as well. You know, when we look at cactuses in the deserts as well, and say, well, why do they have all those spines? And most people would say, oh, well, it's to kind of protect themselves so they don't get eaten, which, yes, is one reason, but also they shade themselves. It's the ridges and the spines of the cactus that keeps them cool. So these architects have also looked at, you know, how buildings can be designed so that they actually shade themselves. There's a company in London called Biome, and they are on the cutting edge of working with mycelium, working with fungi, mushrooms. And so they've been making a lot of construction materials, which are brilliant. You can, using mycelium, you can grow it to shape and form. It's fire retardant, it has super insulation properties. And these guys have been doing great stuff of like getting, you know, into the construction industry, because currently the materials that are used in construction are, you know, not only hazardous, extremely wasteful. And so, yeah, we really need to be kind of focusing on these different forms. Transportation. You know, good example is the humble, beautiful dragonflies that, you know, we see plenty of dragonflies here in the South Downs. And the way they land on any stick or any surface, they're just so, you know, adaptable. But then when we look at, you know, our helicopters, you know, it's so difficult for a helicopter to land. You know, it has to be totally flat. So when it comes to search and rescue, it's really difficult with the technologies that we're using. So they're looking at the dragonflies and saying, well, actually, is there a way to actually copy them in just how easily that they land on any surface? And this is one of the most famous examples in biomimicry, that the bullet train in Japan, when it was first invented, every time it came out of a tunnel, because it was going so fast, it made a big boom. So of course the neighbors were not happy about this, and they, you know, the engineers had to go back to the drawing board. And one of the chief engineers was also a bird watcher, and he watched how a kingfisher can dive into the water without making a ripple. So that's what they did with changing the nose of the bullet train to really elongate it even more, so that when it cut through from one density of the tunnel into another, it stopped the noise. But what they hadn't expected was that it would actually go 10 times faster and use 15% less energy. So it was a win-win situation all round. Airbus have been doing a lot of research with biomimicry. When we all know that, you know, an aeroplane was mimicked from a bird, but they didn't do a very good job. You know, the dimensions of the wings are nowhere near the same. And going back to looking at shark skin as well, of how it could be more aerodynamic and cut through the air better. So yeah, Airbus are one of the companies that are already really looking at how they can improve the efficiency of aircraft. And bats for a long time have been studied, and dolphins with echolocation. But what hasn't been studied so much, apart from echolocation, is the bat's wings, which are totally different from other, you know, birds and dragonflies and other flying creatures. And the interest is they've created this Robo Bat, which again, for search and rescue, if you're trying to go into a cave with a drone, the helicopter style blades are quite dangerous, and they're not very movable either. And so looking at the way a bat's wings, which is more like kind of rubber, you know, like imagining kind of a sheet of rubber that's pulled back, and then, you know, the air pushes it forward. And so, which is, you know, a totally different flying mechanism to what we're currently using in drone technology. So they're looking at, with this Robo Bat, of it having echolocation, of being able to be more maneuverable so it can be used in areas such as search and rescue. Energy, obviously another major topic. And we've got plenty of sun and wind and water, and it's inevitable. We know that the future will be powered by the elements. We're in the kind of the last age of these dinosaur fossil fuels, and the sooner we can get off of them, the better. And so we've got them all around us, but it's about harnessing them and harnessing them in the most efficient way possible. Solar panels, they're very inefficient. And they've been looking at the cabbage white butterfly, which most people, are horrified as they're going to eat all their vegetables. But the good old cabbage white has really clearly shown that, for example, they always sit with their wings at 17 degrees. It's not just a random, they don't just like sit down and just like put their wings flat. To harness the most amount of solar light, the butterflies hold their wings at a particular angle. And looking at, and studying them, they've been able to show that by changing the angles of solar panels, by making them lighter, they can actually amplify their energy by 50%. I mean, this is absolutely huge. But also looking into the nanostructure, looking into the wings of these butterflies that are these incredible solar absorbers. And, even this black butterfly that comes from Asia, which is so good at absorbing solar power. But when they look into the structure of the scales on their wings, and they see how it's got all these holes in it, which actually refracts back the light, that way they can, the future of our solar panels will be able to become much more efficient. Wind power as well. And if you look at a whale, this incredible creature, this huge weight that jumps up through the water, through the air. And when you look at the fins of a whale, they are not straight, they're serrated. And that makes them much more efficient in their way of cutting through the water and cutting through the air. So they've shown that if wind turbines or propellers, and propellers are in everything from, boats to computer fans, to how can we make propellers and fans more efficient? That if the blades had a serrated edge, they would again become vastly more efficient in the job that they're doing. So going back also to the kingfisher they've been looking at, and the maple seed, this maple seed that we can go out and we can find around us at the moment, and looking at their designs about how we can evolve the wind turbines. Because yes, people want to reduce the noise of them, but also we really need to increase the power without having to increase the number of wind turbines. Or we just totally change the shape and look at a whole other shape, which these guys at Caltech have been looking at how fish swim, and how when they're swimming together in shoals, how they actually, the energy that they create together. So these kinds of wind turbines are totally different to what we're used to with the blades. And you can have a lot more of these turbines really close together. Whereas the traditional wind turbines are getting bigger and bigger, and each one needs more space. And they have shown that this kind of technology would need a lot less land, a lot less sea, and could all be built a lot closer together. LED lights as well. We've got here in the park these amazing little glowworms. In fact, last year I helped to do the first ever little study near where I live to find, the last of these little amazing glowworms. And fireflies as well, they were looked into when they created LED lights, because LED lights would not shine very brightly. So what they did was they looked at the stomach of the firefly and found that it wasn't round. Again, it had a wavy edge. So when the engineers making LED lights changed that, all of a sudden, the light shone much brighter. So something that, you know, we see LED lights around us all the time now, but we've never questioned, you know, the kind of the evolution of them, of how they became brighter. But also, I mean, you know, that's a whole fascinating looking at the fireflies and the glowworms and this incredible chemical composition inside them that makes them glow. You know, how that, you know, just amazing. So form and structure. Now, just down the road from us here in Worthing in West Sussex is this little shop called Bowers and Wilkins. And no one would believe that they actually have created the world's best loudspeaker. They only cost £57,000 a speaker, so they're not cheap, but they mimic a snail. So, you know, I've never seen speakers before, and finding out about, you know, this, it's like, well, it totally makes sense. I mean, sound are our eardrums, you know, the spiral of our eardrums. And so how this speaker manufacturer have used that design and come up with, you know, the world's best loudspeakers. But beetles, you know, these little guys are just amazing, and just the colors of them that never fade. They open and close their wings numerous times, and they don't wear out. And what gives them this brilliant, you know, colors without using these kind of toxic chemicals, and their shells are so hard and so resistant. And it's all about actually, you know, the design, the structure, the way that, you know, at a microscopic level, the actual structure of it is a 90-degree angle. It kind of, there's levels and layers of it. And again, it's this, you know, playing with the wavelengths of color. They're not dyed in any way. It's all about to do with the play on light. And this Lexus car manufacturer spent a long time researching and looking into the morpho butterflies so that they could create a color that would shimmer on the car. But we do have to always question, well, it's one thing copying nature, but actually what is the paint made out of? You know, is this truly biomimetic? Is it really using, you know, natural green chemistry that is non-toxic as well in the building of these kinds of paints? And, you know, I always remember I've worked for many years in the Amazon, and I see this butterfly a lot. And, you know, I always think, oh, I'd love to have a turquoise waterproof jacket, because they have these huge wings that is beautiful color and they're waterproof. But if I wanted to have a turquoise waterproof jacket, it would all be made of petrochemicals. The material, the waterproofing, the coloring, the dyes. You know, our obsession with fossil fuels and everything that we use at the moment is still so much based on the petrochemical industry. But, you know, these beautiful beetles and butterflies, and, you know, they're not using any dyes at all, whilst we're using around about 750,000 tons of fabric dyes. And they even say in China, you know what next year's fashion will be by the colors of the rivers. That there are rivers that are running purple and blue and red. And to think that that's still going on, that we are still using these highly toxic dyes in our, you know, in our fabric production. So there's got to be a way of moving away from the idea of dyeing something to replicating what nature does. When we see those butterflies' wings or a peacock's feather, they're not really blue, they're brown, but it's the light, it's the way they work with light that creates the different colors. Now, we can all see different things. A bird never flies into a spider's web, but we can only see spiders' webs from certain angles, how they catch the light. whereas birds can see on the ultraviolet spectrum where we can't. So this Ornilux glass has developed a glass that to us is totally clear, but to birds, they can see it. And they say that 700 million birds a year die from flying into windows. If this could be just a normal part of window manufacture, then there's so many applications for this. Mussels, these mussels all around the world, you find these. You try getting them off of the rocks, they stick so hard. And when they kind of like look at, well, what is it? What is it that makes these mussels stick? And there are some companies now that have done the research. They found out what are the protein molecules that the mussels are using to stick. And how could we use a glue that was non-toxic? Because most of our glues are petrochemical based, and you wouldn't want to drink them. You wouldn't want to put them inside you. And so there's, exciting times ahead with everything from, getting wood glues, which are, formaldehyde super toxic, and which is used in a lot of wood production, going over to these natural protein glues. How coral restoration is held back because they need an underwater glue to stick the corals to the rocks. This can be used as well, these kinds of natural polymers. In surgery, even they've shown in fetal surgery that these can be used. This natural glue can be used inside the body. That's what it does. It sticks in wet conditions. So all sorts of kind of like pharmaceutical applications as well, looking at how a honeybee or a wasp, or the ultimate is the mosquito, very, very different to a syringe, how totally serrated the edge of the needle is, which means you don't feel it as much. And this beetle, which is also found here in the park, the Bombardier Beetle. I don't know how many people know what the relationship is between Charles Darwin and this beetle. And story has it that he was out collecting beetles one day, and he ran out of space in his hands to collect them. And so he put one in his mouth, as you do. And all of a sudden, his mouth was on fire. He spits it out. And it was later discovered that this beetle, inside its body, it mixes together two chemicals, which creates this burning liquid, which is then expelled at a high pressure out of its rear end. So, it's like, okay, how do these creatures, like mentioning earlier with the glowworm, how do they create these chemical interactions inside their bodies without burning themselves? And, and how they're expelling it. So, the different ways that we are learning about creatures, like we've never looked at them before. This Namib beetle has been getting a lot of press when it was discovered that in the desert, where there's no water, this little beetle, it runs up the sand dune and it waits on the top of the sand dune in the morning. And the fog that in the atmosphere is actually attracted to its black shiny shell, which has lumps. And the water, the humidity in the air is attracted to the surface of the beetle. It then leans forward, which it has these little kind of gutters that direct the water straight into its mouth. A genius invention. They've gone on to say, well, actually, we could build in the desert these big greenhouses and collect water in the desert. And now there's this company that has created a water bottle that actually just fills itself through condensing the water into a bottle. So there's so many applications as well that we can learn. Can we get roofs to actually collect water? There's so many areas now, and as the climate is heating, we really need to find ways of those that are living in very dry areas. How do we actually find water and pull it out of the atmosphere without having to rely on rain or desalination? So, the fact that they've created a self-filling water bottle almost seems magical. But using this kind of technology and looking at how do we green the deserts, that yes, can we capture water out of the air, but also using desalination processes where the byproduct is salt. And they've said, well, actually, rather than this being a problem, that it can be turned into building blocks to build with. That using concentrated solar power in the deserts with mirrored technology, that we're still not talking enough about that. We still think about solar and we just think about solar panels. But, one tiny little mirror can create a fire. So having these huge mirrors all pointing at a central location creates huge amounts of power. So the Sahara Forest Project have been really looking at that, greening the desert and how to actually grow food and find water in the deserts. But the sun, if we were wallowing around like a hippo in the sea or in the swimming pool, we would be getting really burnt. So how does a hippo lie around in the African sun all day? And whilst we cover ourselves in petrochemical sunscreens, the hippo just has this kind of a mucus that goes all over its skin, which protects it from the sun. Again, another natural solution, protein-based molecules, which the hippo is covering itself to protect itself from the sun. So materials, this is where we're really kind of starting to look deeply into learning from nature. And one of the leading lights was Ray Anderson from Interface Floor, who's one of the biggest carpet companies. And he said, we realized that we were part of an industrial system, a take, make, waste, a linear system that's literally digging up the earth and converting it to rubbish. And of course, it can't go on. The earth is finite. He spoke about we need to love carbon and we need to lead an industrial revolution. Now, we look at kind of carpets, and they're a really good example of something that's pretty toxic. They're made out of petrochemicals. They use a lot of glues. There's a lot of waste. They would have specific color runs. And if the color wasn't exactly right, and it got close to the end of a run, loads and loads of waste, loads of carpet gets thrown away. So they took the whole of their, from all different areas of the company, were taken out to the forest. And with Janine Benyus, they went and they looked at the forest floor and they saw that no two leaves are the same. And this idea came up of creating new carpet tiles where they didn't need to match. They didn't need to have the same color runs, that they could be designed so that when they wear out, just those ones that have worn out are replaced, which really cuts down on the amount of rubbish that there is. So looking at this is a totally different idea, that also saying, well, also how do we stop sticking the carpet to the ground? And they were inspired by a gecko's feet and how it sticks to the ceiling, and created little corner tabs to actually join them together. So, they have really been one of the leading lights in biomimicry and really, encouraging big businesses to turn what they're doing around. And if a carpet company can really be leading the way, then, there's hope for so many other industries. There's a company called Impossible Materials, and they've been looking at this incredibly white beetle. because titanium is the most used colorant on the planet. Now, everything from all of the markings on the roads through to toothpastes and paints and sunscreen, and there's so much that uses this titanium. But what we forget is that it's quite toxic, the mining process. We can't keep relying on mining and contaminating the environment where we get the titanium from. So when we identify the problem, then it's about, well, okay, the problem is we're using vast amounts of titanium. It's super toxic. How do we learn to create another cellulose-based white? And that's exactly what they've been doing, is learning from the structure of the beetle of how we can create a whole new material that is white. So one of the greatest producers of material is the spider. I mean, this kind of superhuman, the actual webs are the strongest material that is known. And we keep creating, Kevlar and all these like super strong materials that again made out of petrochemicals, but they're still not as strong as a spider's web. And so instead of just kind of looking at the nice spider, people have been asking the spiders the right questions. Out of dead flies and water, how do you make one of the strongest materials known? And there are companies that's exactly what they've been doing. Because what we can't do is, get these beautiful golden orb spiders and say, right, well, we're going to get millions of spiders and we're going to put them all in a room and we're going to harvest all of their web and make these beautiful golden gowns. That really can't be the future. Instead, we have to learn from them. But how are you producing this beautiful golden silk? And there's a couple of companies, Bolt Threads, they have come up with this vegan silk and have made this beautiful tie here, is made this new generation of silk. And now Spintex, who are one of the Ray Anderson Prize winners, have actually learned from the spider how they spin it as well. So it comes inside the spider, it's in a gel form. And the way that the spinneret produces it strings out the protein molecule into this new silk thread. And there's a part of me, a forever vegetarian and an absolute animal lover, that is really concerned about, how are we exploiting animals in this way of biomimicry, this way of learning from them? And there's going to be a very fine line in this. But, thankfully, the people that are in this field are really aware of that. And it's like, actually, do we have to, what we really need to know is learning, and we're reverse engineering what the spider is doing. What protein molecules are in that spider's web so that we can learn from them and copy them. Mushroom clothing as well, kombucha, kombucha is just becoming a big thing, this amazing fermented drink, and it grows like leather, and it grows to whatever size container it's in, really. And so this is another kind of like vegan alternative to using animal skins. So we'll be seeing a lot more of these kind of like man-made fabrics, but they are a fabric that can be broken down in our compost piles afterwards. So moving away from petrochemical fabrics, all the nylons and the polyesters and the fleeces and the plastic bottle jackets and all of this that comes from plastic, which creates microplastics. We have to move into looking at naturally based fibers. But fibers like cotton, although they are natural, they have huge environmental impacts. So actually, is the future of clothing growing clothes? And using waste. There's a huge amount of waste in pineapple skins, and they have found that that also creates an amazing leather. So turning something which was once a waste product into a new leather, a new kind of whole world of fashion is also the future. So waste not. This is nature. Here on the right, here we've got here, these beautiful bluebells. And, once they've died back, they die back into the ground. And, it's this constant cycle of branches fall and they rot down into the ground. And then we look at this kind of human waste, which we're all so aware of, this just hideous piles of plastic, which still only 3% is actually recycled of the plastic in the world. The petrochemical industry produces 300 million tons of plastic. We know we've got to move. We've got to find the solutions. Now, one of them is this amazing solitary bee from New Zealand, which creates kind of like a cellophane wrap around its young. And one of the things that they talk about a lot is the sin list, which is, in the chemicals, it's the substitute it now. As soon as possible, we need to move away from some of the chemicals that we're currently using. And in a lot of plastics, in a lot of petrochemicals, it's seriously harmful. So to make plastics or to make fire retardants, which this wrapping that this Hylaeus bee produces, not only is it water repellent, but it's also fire retardant. And fire retardant chemicals are amongst some of the most toxic chemicals that are known. So they've looked at this wrapping that the bee is producing and say, well, yeah, it's waterproof, it's fire retardant. It also, again, they've tried it with petrol, with chemicals, and it's totally resistant. So, the future in these materials. There's also another company called Air Carbon, who's, learned to suck the carbon out of the air and turn it back into carbon pellets, and are making all sorts of things, everything from plastic, what looks like plastic, and everything from Body Shop has just made a contract with them for all their tops. So there will be this new use of plastic being sucked out of the atmosphere, being made back into something. Yeah, it's another one of the solutions. And the company New Light Technologies are doing some really great stuff. So any of these companies are really worth kind of looking into what they are doing. Along with Biome, who I spoke of earlier, working with mushrooms, creating all sorts of agricultural waste, insulation, building blocks, acoustics. They are working in that way. And again, another amazing company to keep an eye out for. So here we have the periodic table, 118 elements. But according to the Biomimicry Institute, nature only uses 28 of them. So everything from, the hardest abalone shells going through to kind of gelatinous mushrooms and, all the bones and skin and tissues and cells and all the different materials that are made, only nature is using 28. But a lot of them, are kept deep, deep down in the ground, under deep rock, because nature knows it's like they are toxic and they don't want to be bought and mined above ground, which is exactly what humans have been doing. So we have been using 350 polymers in different kinds of plastics. Nature only uses 2 polymers, proteins and polysaccharides. So this is where we've come from, and we're kind of trapped in this world of chemicals and plastics and where we need to go to. And we have the greatest teacher to learn from. Because green chemistry is absolutely the future. And the sooner we can kind of move that way, the better for all life, not just for us humans that are washing our hair and our clothes and using chemicals in our own personal toiletries, but in the manufacture of so many things, we are still using highly toxic chemicals. And nature does its chemistry in water. It's water-based. So nothing that is produced has a toxic buildup. And when we look around, I really encourage you all next time you're out for a walk anywhere, start to look for the patterns. Identify where there are patterns and what these patterns do. What's the reason for them? Why have they evolved into this shape and this form? This sacred geometry, which we see throughout the living world, these beautiful designs, these amazing shapes. I mean, of course, nature loves beauty, but there are other reasons why they hold these shapes. One good example is known as Murray's Law. We see this branching technique. We see it in our own bodies, in our lungs, in our arteries, in a leaf or a tree or a river. There's this same branching. And the reason that nature uses this pattern is because it's the best way to move water or move gas. So what do we do when we're moving water? We use straight pipes, or if we're moving energy. But could we actually design the future that it actually had much more of a branching pattern, which would enable that everything used less energy and was more efficient? Because the futures and the cities of the future are going to look very different. The growing of food in the future, it's going to be vertical. We won't be just growing food on a big flat field. We will be growing food vertically using that space. Cities of the future will have green on the buildings. Not only will they be growing food on the buildings, but also it makes a lot of sense. By having green walls, it keeps the buildings cool in the summer and it insulates them in the winter. And obviously improves the quality of the air. It's better for your mental health to live around where there's more trees. So this is the architects were asked by the city of Paris in France to give a version of what they thought the city would look like in 2050. But already buildings are changing. In Milan, in Italy, they have created this amazing skyscraper, absolutely covered in plants. They've also got the Italy Pavilion, which absorbs air pollution. The Bullitt Center in Seattle has been made closed loop. It produces its own energy. It deals with its own water and its own waste. And then we look at these traditional thatched houses in the UK that were made from on-site materials. Our ancestors that built these houses, they built them from the local resources right where they lived. So, it's about learning from the past and how we will adapt for our life in the future. And already there's this kind of merging of nature and tech. This does exist, this E-tree, where the solar panels act as the shade, but they also produce light. You can sit underneath them at nighttime, it will light up. They've even got it creating water catching off of the panels. Communication. There are these amazing slime molds that are found here in the South Downs National Park and all over the world. And there was a great little documentary I recently watched called The Blob. And they showed that they got slime mold from America, Australia, and Japan. And in Japan, they've been working for a very long time with slime mold. And they discovered that the Japanese was the most intelligent, the American was the greediest, and they still cannot understand how what the intelligence of slime mold works. This map here is the mapping of the Tokyo transport system, which they have been learning from slime mold, how quickly it works out the quickest route from A to B. So, the applications to use and to learn from this, single-celled organism without a brain that is showing an incredible intelligence, and how this can be used in everything from transport systems to computer software, just like they are doing learning from the bees and the ants in improving communication software. So some of these major lessons is that, life runs on sunlight, not on fossil fuels. It does its chemistry in water, not toxic, and low temperatures. Everything is connected to everything. No organism can survive on its own. It is cooperation, not competition, sharing and contributing usefully. And evolutionary success is where organisms add value to their local environment and not take more than they need, which is where we need to question ourselves. Are we adding value to our local environment? Are we taking more than we need? We talk about this buzzword to be sustainable, but does this apple tree create a sustainable amount of apples? No, it's thriving. It creates an abundance. I'm finishing with Janine, another great quote of hers. Nature, by necessity, has already solved many of the problems we are grappling with. Animals, plants, and microbes are the consummate engineers. They have found what works, what is appropriate, and most important, what lasts here on Earth. And these are the principles that we really, really need to learn. Like I said before, nature runs on sunlight. It uses only the energy it needs, fits form to function, recycles everything, rewards cooperation, banks on diversity, demands local expertise, curbs excesses from within, and taps the power of limits. So these are the principles we need to kind of build on. But here's a little test for you all to do as your homework. Choose a foot, any foot, and think about the adaptation of that foot, why it is the shape that it is, what does it do? And think of a human problem that we're currently experiencing and see if you can come out with some crazy, amazing solution. This is where we need to start really using our imaginations, which seems to be in short supply at the moment, and to allow our minds to expand, to not be focused just on the problems, but to start looking at the solutions and see how we can marry them together. We learn from these amazing water bears, these tardigrades, known as extremophiles. They can live for years without a drop of water and then be rehydrated. They can live in the hottest places on Earth, the coldest places on Earth. They've even been blasted into space by NASA and they've still survived. What can we learn from them? But we have to really, look in a reverence to nature, this incredible world all around us, and to really kind of learn from it. So ways that you can after this is look on the Biomimicry website, the Ask Nature website. These have been designed to be sharing platforms where if you have a question, how do you filter water? You ask nature and it will show you, how do the kidneys filter water? How do mussels? How do fish? There's many, many different ways. And so having these platforms will help everybody to move on quicker. Every year there is the Biomimicry Global Design Challenge, and it's the greatest students in the world, greatest minds that are coming together and actually looking at some of the greatest problems we have and coming up with some amazing solutions. So bringing that back locally here as well, we are starting a kelp, big kelp restoration project in the south of England. And something which was one of the winners of the Biomimicry Prize was this company called Drilgy, which seemed really strange. But looking into it, I'm like, okay, this could really help us. If we're going to be growing masses of kelp that not only sequesters carbon, but has huge seaweed, can be used in so many ways as biofuel, as food, for toiletries, for cosmetics, for medicine. There's so much that can be used with seaweed. Seaweed is another major ingredient in the future. But when you harvest it, it's very heavy and it's very wet. So how do you dry it? Because to transport it, it's going to need to be dried. And this is exactly what this group came up with: a drying machine for seaweed that doesn't need any power. And they've learned from a camel's nose, a moth's eyes, and the shell of this beetle. And it was learning from them that they came up with this design. So there are so many amazing ways that we can identify a problem and look at different aspects in nature to be able to solve those problems. And anybody that lives around locally in the South Downs National Park, I'm also leading biomimicry walks. So there's a new wild art trail with this virtual reality giant, and each of the markers talks about a different animal, the owls and the bats. And so I'm putting a different twist on it and also talking with each of those animals about the biomimetic properties that they are teaching us. So just to wrap up and give thanks to the South Downs Educational Network, who have got myself and other people that are doing environmental education, that they are offering all sorts of amazing sessions and activities so that, teachers and students can, learn outside of the classrooms as well, not just have to be inside those four walls. And if there's anybody that is interested within the park on learning more, they're offering all sorts of grants. I can also give talks to any schools and the grants will cover that. And just seeing what the national parks are offering, and they're doing some great stuff with environmental education. So do check out what they are doing. So I'm going to leave that there. If you go onto my website, nicolapeel.com, there's a link there, some videos, biomimetic videos, and my old website, Eyes of Gaia, which is desperately needing updating, but I'm too busy to do it. But that has a huge amount of environmental information on it. So I'm just going to stop sharing, come back to you all. Anyway, I hope that big download has given you some kind of inspiration and something to think about. So I'd really like to kind of hand over to you, Ness. Is there any kind of questions or comments? So Carrie had to rush off, my co-host. So I will just bring up the chat box. And could you send the links? Yes, I will. There's a whole load of links that I will send out to you from this evening. So that, I will definitely be doing that. So great presentation. What are my thoughts on COP26? Well, I've just got back from COP26. I was actually there for 2 weeks, and my answer is always there's not enough focused on real solutions. We focus a lot on the problems, but we're not focusing anywhere near enough on the real solutions of what we really need to do. So that's definitely my feedback. Probably the most eye-opening talk I've ever listened to on Eventbrite. Well, that's saying something. Great. Yeah, I know there needs to be a lot more of us that are talking on biomimicry. And so anyone that's also at any kind of educational institutes, universities, and feels that this would be a good presentation, then please contact me. I'm really, really interested in getting into as many educational places as possible, because we need to inspire the youth, the business leaders of tomorrow on what the future must look like. And if we can't see the future, we're never going to get there. So it's really important that we learn from companies that are already on it, they're already doing it, and what more we can learn from nature. So is there any other questions out there? Or you're all just overloaded with this huge amount of information? So I think that that's are financial investors aware enough to redirect clients away from fossil fuels? Well, fossil fuels are an interesting one that as we saw throughout this presentation, we are so addicted to, whether that's in the clothes that we wear or the vehicles that we're moving around in, or all of the plastics. Fossil fuels are in everything. And a part of it, I really believe in the design, that we need to move away from fossil fuels, but we need to also create a demand for it. And, all the time people are still driving and flying and using it all. There is still a market. We live in a world of supply and demand. So although we desperately need these companies moving on and moving away from fossil fuels, we also as individuals need to do our bit and start refusing it. And so I think it's really important that we don't give away our own personal power. And we look at, how much, what's our own contribution, what's our own use of fossil fuels, but also actually, what does the future look like without them? And are we a part of that? So I've just had another one here working for, I'd like to, is a speaker focusing on architecture. Yep, you can contact me. Anyone can contact me through my website, nicolapeel.com. So I will send that through in the links, but yep, I am able and open to speak for any organization. So just do let me know. So I did run over a little bit there. If there's any other last questions or comments, I'll have lots of thank yous. So I'm glad that people enjoyed the presentation, and I hope that you are in some way inspired and in awe of the amazingness of nature, if we weren't already in awe. But that's really what this is about, is looking at the real examples and how we need to get from where we are, and especially for the youth, where there is so much eco-anxiety about the future. I think that biomimicry gives us so much hope. It gives us so much possibilities that we can create another world where, we're working in harmony with nature. So I want to thank you all for coming. And I do occasionally do other Eventbrite, so you can sign up on the Eventbrite page. If I do I do a few other talks on biodiversity as well, and my other work that I do. But I will follow up this with the links and my websites and loads more information on biomimicry for those of you that want to learn more. So thank you all for coming, and have a good day, night, wherever you may be in the world. And yay, thank you, Irene, for clapping, and Marcella. So yay, thank you all. Bye-bye.
Thank you, bye.
Thanks, bye-bye.
Thank you, Nicola.
Thank you.
Thank you.
Cheers. Save chat.
Thank you again, Nicola, from France as well.
Thank you.
Be in touch.
Yeah. Okay. Thanks a lot then. Bye-bye.
Bye-bye.